This is question 4 of the AQA Physics Unit 1 June 2014 paper. This question says a note was played on an electric keyboard. The frequency of the note was 440 Hz. You are then asked, what does the frequency of 440 Hz mean? Now this question is assessing whether you understand the term frequency and also if you can relate a unit such as Hertz to a physical quantity. So 440 Hz is what you're given in the question. Now what that means is you've got 440 waves passing a fixed point every second. Because that's what frequency is. Frequency is the number of waves passing a fixed point in the second. 440 Hz means you've got 440 waves passing a fixed point every second. So you can now, I've just dropped in there the actual answer, which is this bit here that I'm moving around. I'll highlight it for you. So you can see that you get the answer for being 440 sound waves produced in 1 second, or 440 waves being produced in 1 second, or passing a fixed point every second. That's the key thing you need to get from that question. In A part 2, it tells you that the sound wave produced by a keyboard travelled at a speed of 340 meters per second. I'm just going to circle that for later. You're then asked to calculate the wavelength of the note. It says use the correct equation for the physics equation sheet and give your answer to 3 significant figures. Now just drawing your attention to the fact that it's a 3-mark question. The 3 marks will be as follows. You get 2 marks for getting the correct answer, and then the third and final mark for getting it correct to 3 significant figures. Now the next bit is to correctly choose the correct equation. So I was going to write in some information from earlier. So we knew that the frequency from the last question was 440 Hz. Now you need to use your equation sheet to find an equation that links wave speed, wavelength and frequency. And you should get that V equals F times lambda. So we'll write that down. Now let's stick the numbers in just so we've got them. So wave speed is 340, that's what V is, so you get 340 here. That equals my F, which is 440, multiplied by my wavelength. Now wavelength is given by the lambda symbol here, and this bit that we've just done so far, so if you wrote this line that I've written there, you get 1 mark. Now I want to rearrange to get our wavelength, which I've given using lambda. So that would be lambda would equal 340 over 440. I can put that into my calculator to get an answer of. Now once you put that into your calculator, you get an answer of 0.772727, and that repeats. Now it asked you in the question to give that to 3 significant figures. So your correct answer should equal 0.7, that's 1 significant figure, 7 2 significant figures, so the third significant figure will be 2, but you notice I've got 7 next to it, so I have to round up to 3. And that should be written in meters. And that part there will get you all 3 marks. In the final part of the question, you're asked to compare 2 oscilloscope tracers, Fig 4 and Fig 5. And it asks you to what 2 conclusions should be made about the second sound wave produced compared to the first sound wave. So let's have a look at them. So the first thing you'll notice, I think that's the most straightforward, is that you've got a higher height or amplitude on that one, which means it's a louder wave. So the second one is louder. That's 1 mark. The reason being it has a higher amplitude. That's the first mark for that question. And the explanation that I've just written there is 2. So you got 2 marks for getting the correct statement. So the wave is louder, and the next bit is for explaining why it has a higher amplitude. So let's have a look for the second thing that we notice about the difference between the 2 waves. If we take this, we can see we've got 1 wavelength. That's 2.5 wavelengths that we've got there. Whereas with this one we've got 1, 2, 3, 4 waves. So let's have 4 compared to 2.5 waves, which means that this one for the second wave is more frequent. The second wave has a higher pitch. Or is more frequent. And why do we know that? That's because there are more waves displayed. And that will get you the 2 marks for that question. Just to summarise very briefly then, you can see that these are the complete answers all shown on one slide for that question. The idea is you get sound wave is louder, that's the first mark, and the amplitude is larger. The next mark comes for the idea that it's got higher pitch or frequency, and that's because you can see more waves on the screen. And it's a combination of those in that order, so you have to have the idea that it's louder with the correct idea that the amplitude is larger, ties in together to get both marks there. Then the higher pitch frequency, more waves seen, you have to tie together to get the 2 marks as well. If you've got them in the wrong order, you'd lose marks in this question.